Welcome back. Hopefully you've had a relaxing break. You've taken the opportunity to make yourself a nice cup of tea. I've got my dog sitting on my lap, so apologies in advance if there's an occasional bark, but she wanted to join in the trigonometric fun today. All right, so just a few more examples. This one is a cosine function. And I'm going to do again, same thing that I did in the previous example. First begin by simplifying our function, or rather rewriting our function. I'm going to factor out the 3. And when I factor out the 3, that will leave 2 pi over 3 behind. And the number in front here, the 3, is already positive, so I don't need to worry about using my symmetry properties of cosine, so that's kind of nice. So let's think about the period here. The period, of course, would be 2 pi divided by 3, and for our subintervals, the length of those intervals would be 2 pi over 3 times a quarter, which would be then pi over 6. So our tick marks before we do our phase shift are going to go up by pi over 6 at each step. So let's start by getting our little table of values for our 5 key points. We would have 0, we would have pi over 6, there would be 2 pi over 6, there would be 3 pi over 6, and there would be 4 pi over 6. And same thing that I said before, I'm not simplifying these numbers yet because, of course, we're still going to be applying a phase shift, and so I'll do the simplification once that's all said and done. Now, we said here that the function that we were graphing was negative 5 cos 3 times x plus 2/3 pi. So the value for a is negative 5. And for a cosine function, we know that we start at a, then go to 0, then negative a, then back to 0, then back to a. So we start at a, which is negative 5, then go to 0, then go to negative a, which would be positive 5, then to 0, and then back to a again, which is negative 5. And now, after the phase shift, so now we have to think about what kind of transformation we'll be doing to those x-coordinates. And so for our phase shift, we had that it would be a phase shift to the left. Our phase shift would be negative 2 pi over 3 because we'd be shifting our graph to the left by 2 pi over 3. So what we're going to do then is subtract 2 pi over 3 from all of our x-coordinates. And so now let us do that. Let's make ourselves, again, our little table of x values. And so 0 minus 2 pi over 3, that's negative 2 pi over 3. Pi over 6 minus 2 pi over 3, that would be negative pi over 2. Again, if you're having trouble doing the subtraction, just ignore the pi for now. Instead of thinking about pi over 6 minus 2 pi over 3, think about 1/6 minus 2/3. And 1/6 minus 2/3 is negative 1/2. So that's where the negative pi over 2 is coming from. Okay, continuing along, 2 pi over 6 minus 2 pi over 3 gives me negative pi over 3. 3 pi over 6 minus 2 pi over 3 gives me negative pi over 6. And 4 pi over 6 minus 2 pi over 3 gives me 0. And of course, the y values are unchanged because we don't have a vertical shift for this graph, just a horizontal shift. All right, so now we've got our 5 key points. So we'll be starting at negative 2 pi over 3, and with the x values, negative 2 pi over 3, negative pi over 2, and so on. And let's go. I've got my tick marks already set up. And as we had before, notice that the tick marks that I have on the left side and on the right side, of course, there's the symmetry there. We have a negative pi over 6 and a plus pi over 6, a negative pi over 3 and a plus pi over 3. All of our tick marks are going up by pi over 6 because that was the length of our subinterval. And we said that we would be starting with our y values at negative 5. So we'll start out with a y value at negative 5 when x is negative 2 pi over 3, then up to 0, then up to 5, then to 0, then to negative 5. I think that's not quite 5 there. Let's just fix that one, make that look a little bit better. There we go, and I'll connect the dots as best as I can. And there we go. That's one period of the cosine function that we've got. And I can continue on for a second cycle, going to 0, then up to 5, then back to 0, then back to negative 5. And of course, I should be labeling these 4 points. So I'll do that over here, negative 2 pi over 3 with negative 5. This one is 2 pi over 3 with positive 5. This one is pi over, with negative 5, sorry. Try that again. That was 2 pi over 3 with negative 5, rather. All right, so we have up top, that would be pi over 3 with positive 5. And this coordinate over here on the left, that's negative pi over 3 with positive 5. And those would be my points that I've labeled. So I've got, and also notice that I have my equation labeled. This time I had it typed in already in advance. So as always, our tick marks are labeled. The x-axis is labeled with its tick marks, so is the y-axis. Any points that aren't on the axis, x or y, any of those key points, we'll need to label them, and that's what I've done there. And there we go. We have the graph of a nice transformed cosine function. Let's do another one. This one, another cosine function, but we've also got a vertical shift as well. First, just to rewrite this, we have y equals negative 2 times cosine of 3, factoring the 3 out, x minus pi over 3 plus 2. So we have a transformed cosine function. I'm just going to rewrite that. There we go. A transformed cosine function where, in addition to the vertical and horizontal stretches, we've also got ourselves a phase shift of pi over 3 positive. We'll be shifting our graph to the right by pi over 3, and we'll also be shifting our graph upwards by 2. So we'll have a horizontal shift as well as a vertical shift. So, usual business here, talking about our period. For this graph would be 2 pi divided by 3. I was lucky again because, of course, the number b was already positive, so I didn't have to deal with the symmetry property of cosine to make that simplified. So period is 2 pi over 3, and for our subintervals, the length would be 2 pi over 3 times a quarter, which simplifies to give you pi over 6. So we'll have pi over 6 as the length of our subintervals, and so we'll start at the origin we'll start at the x value of 0, And each x value after that will go up by pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. And for our y values, since it's a cosine function, remember for cosine we start at a, and then to 0, then to negative a, then to 0, then to a. Here a is negative 2, so our y values will start at negative 2. We'll start at a, then go to 0, then to negative a, which is positive 2, then to 0, then back to a again. And now we have the two shifts that we need to apply, the vertical shift and the horizontal shift, the phase shift and the vertical shift. The vertical shift is the easier one to do. I'll do that one first because we were going to be doing a vertical shift upwards by 2 units. It was plus 2 at the end, which means we will be adding 2 to every y value. So for our y values for our key points, we'll be adding 2 to them. Negative 2 plus 2, 0 plus 2, 2 plus 2, 0 plus 2, negative 2 plus 2. So our y values will start at 0, then 2, then 4, then 2, then 0. Now for the phase shift, we are carrying out a phase shift of positive pi over 3. Positive because we're shifting to the right by pi over 3. So I will be adding pi over 3 to every x value. So let's do it. 0 plus pi over 3, that would be pi over 3. Pi over 6 plus pi over 3, that would be pi over 2. And 2/6 plus pi over 3 would be 2 pi over 3. And 3/6 plus pi over 3, that would be 5 pi over 6. And then lastly, 4 pi over 6 plus pi over 3, that would be just pi itself, 6 pi over 6 or pi. So now we have our tick marks for pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi, and those y values, 0, 2, 4, 2, and 0. So we will get our x-axis set up, we'll plot our points, and then we will see what we get. So I have my x-axis set up, and we had that our first point was at pi over 3 and 0, then pi over 2 and 2, 2 pi over 3 and 4, 5 pi over 6 and 2, and pi and 0. So we have one cycle of our graph. We'll make the little dots more apparent. There we go. And if I wanted to continue another cycle, this time I've decided to put it on the left of the first cycle that I drew rather than on the right of the first cycle that I drew. So we would go up to 2, and then to 4, and then to 2, and then back down to 0. And there we go. Now we should be labeling these points, and unfortunately I do not think I'll be able to fit them all in with the stylus that I'm working with. I can't write quite as fine point as I would like, so just keep in mind that if I were doing this on the blackboard, my next step that I would be doing would be to label all of those points that I've got in red. I'll label some of them, I won't be able to label all of them. Negative pi over 6 and 2, I can label that one. This one, I might be able to fit it in pi over 6 and 2. This one I can fit in 2 pi over 3 and 4. and this one 5 pi over 6 and 2. And this one I don't think I have enough room to fit it in. Maybe I do. I'll put it down below. Ooh, maybe I'm getting it done. Yay. That's a fun surprise. Okay, I'm just going to make that look a little bit nicer. There we go. So I have my graph labeled, I have my points labeled, and there we go. We have our transformed cosine function that's been shifted upwards and also shifted with a phase shift as well. All right, one last example. This one's going to be a shorter example because I'm only going to do one cycle of this graph, only one cycle of this sine graph. And for this one, we start out again, as always, by rewriting things. So we have y equals 3 sine of, and I'll factor out that -4. So that would be x minus 3 pi over 4 plus 1. Or sorry, it wasn't plus 1 at the end, it's a -1 at the end. There we go. And now I'm going to deal with the symmetry of sine, the odd symmetry of sine. Since sine of negative x is negative sine of x, that means that that little negative in front of the 4, I can take that outside. We can say that y is actually equal to -3 sine of positive 4 times x minus 3 pi over 4 minus 1. Okay, so I will start out with my first move being thinking about my period and the subinterval length. So again, period, easy enough to find. That would be 2 pi divided by 4, which would be pi over 2. And for our subintervals, the length of those subintervals would be pi over 2 times a quarter, or in other words, pi over 8. So we will have our x coordinates on our x-axis each time going up by pi over 8. So I'll start off with the function without the phase shift and the vertical shift. We'll find the 5 key points for those. And so our x values would be starting at 0, then pi over 8, and 2 pi over 8, and 3 pi over 8, and 4 pi over 8. And I'm not doing any simplification yet, because again, I will be doing a bunch of shifting afterwards, so it doesn't make sense to do a lot of simplification up front here. So those values, 4 pi over 8, yes, it does simplify to pi over 2, and I'll deal with that at the end. So next, y values. We are looking at a sine graph. Sine graphs start at 0, then go to a, then negative a, then 0. And our value for a is -3. So that means we are going to start at 0 for a sine graph, then a, then 0, then -a, then back to 0 again. So our points for the y values, our coordinates are 0, -3, which I'm just going to make that look a little bit nicer, 0, 3, and 0. So now, after the shifts, we've got shifts that are happening to the x values as well as to the y values. So for the y value shift, we have a shift that is going to be downward by 1. We're going to be subtracting 1 from all of our y coordinates. So let's do that now. We'll take all of our y coordinates and subtract 1 from them. 0 minus 1, negative 3 minus 1, 0 minus 1, 3 minus 1, 0 minus 1. So I've got my y values taken care of. And next, we have to take care of our x coordinates. And for the x coordinates, we are carrying out a shift to the right, a positive phase shift of 3 pi over 4. We'll be adding 3 pi over 4 to each and every x coordinate that we have. So let's do that. So 3 pi over 4, or same thing as 6 pi over 8, that would be 0 plus 3 pi over 4 is 3 pi over 4. Pi over 8 plus 3 pi over 4, that's 7 pi over 8. Something to notice here, I mean, this also may help you with your calculations. My tick marks are still going up by pi over 8. Like, notice that this 3 pi over 4, that's 6 pi over 8. This is 7 pi over 8. The next one should be 8 pi over 8. And, of course, 8 pi over 8 is the same thing as pi. The next one should be 9 pi over 8. The next one should be 10 pi over 8, which is 5 pi over 4. There we go. So we have our 5 key points. Now, one thing that you might think about here is when I say graph one cycle, there are infinitely many cycles that you could graph. So these 5 points, that is one cycle of my transformed sine function. But if I were to take my x values and shift them downward or shift them upward by one full period, remember here that we said for this graph, the sine graph that we're looking at, the period is pi over 2. That means if I were to add pi over 2 to all of my x coordinates or subtract pi over 2 from all of my x coordinates, that would give me another cycle. So what I could do, and this is what I'm going to do here just for a little added fun, I'm going to take the transformed x coordinates that I already have, and I'm going to shift them to the left by one period. I can subtract pi over 2 from all the x values, and that will just give me another period for my graph. So if I were to do that, and I'll do that on the next page, so we would have 3 pi over 4 minus pi over 2. We would have 7 pi over 8 minus pi over 2, pi minus pi over 2, and so on. So I will take all of my x coordinates that I have, and I'm going to subtract pi over 2 from all of them. I'm moving everybody to the left by one full period. So 3 pi over 4 minus pi over 2, that's pi over 4. And then the next one, 7 pi over 8 minus pi over 2, that's 3 pi over 8. Notice again, my tick marks are still going up by pi over 8. This is 2 pi over 8, 3 pi over 8. The next one should be 4 pi over 8, which is the same thing as pi over 2. 5 pi over 8. 6 pi over 8, which is the same thing as 3 pi over 4. And since we've just shifted our entire graph to the left by one period, then that means the y values are going to be the same as for the first period that we looked at. This first cycle has those y values, -1, -4, -1, 2, and -1. And those would also be the y values for any other full cycle that we might want to do after shifting to the left or to the right by a full period. So the y values will be same as before, -1, -4, -1, 2, and -1. And so now I'm going to plot these. I do want to say, though, that if you felt like it, you could graph these points, and that would be fine. Or you could, if you felt like it, graph these points instead, and it would also be a cycle. Remember that when I'm asking you to graph one cycle of a particular trig function or two cycles of a particular trig function, I don't have a particular cycle in mind. Any cycle will work. So this one starting at 3 pi over 4 and ending at 5 pi over 4, yes, that's one cycle of our graph. But so is this one, starting at pi over 4 and ending at 3 pi over 4. So I'm going to graph this one, starting at pi over 4. And our y values were, at pi over 4, -1. At 3 pi over 8, it was -4. At pi over 2, it was -1. At 5 pi over 8, it was 2. And at 3 pi over 4, it was -1. And I will connect my dots as nicely as I can. That did not look as nice as I would have liked. I'll try that again. Moderately okay. And so my 5 points that I have here, I would have to label all of these, and I really don't have room here to fit in the labels for all 5 of those points for their coordinates. But this would be the graph of my transformed sine function. Something that I just wanted to mention as sort of foreshadowing for Chapter 8, you might notice that this graph of this sine function is crossing the x-axis in 2 places, here and here. And if you were wondering, how could we find those x-intercepts, we would need to be able to solve this equation, solving this equation for x. And just as we did when we talked about exponential functions and how to solve an exponential function, we needed an inverse. Similarly, to solve a trigonometric equation involving sine or cosine, we'll need inverse trigonometric functions. And that's something that you can look forward to when we look at some of the things in Chapter 8. All right, take a well-deserved break, and I will see everybody, or I'll digitally see everybody shortly when we start Chapter 8, which will involve inverse trigonometric functions.